Hey everyone, welcome back to the channel. If there is one thing that frustrates every test automation engineer, it is a flaky test. You know the story. A test passes on your local machine but fails in the Jenkins or other CI/CD pipeline and then passes again when you rerun the same test without changing any code. So these are the flaky tests that waste your time and they break team trust in automation. Most of the time, flakiness happens because your script cannot handle dynamic elements and changing page states cleanly. So in this video, we will fix that problem step by step. We will cover why dynamic elements break scripts and the common mistakes to avoid, and also we will look at some best practices directly from the official Playwright documentation. So first of all, let's look at this dynamic demo page on the expand testing. So you can see here when I load the page, the layout shifts randomly. You see a black shift in the menu here. So here, if your script uses a weak locator like dynamic CSS class, a hard-coded position, or a long parent XPath, your test breaks as soon as the layout shifts. So the next time test runs, there is a shift in the layout, and you can see to stop this flakiness, your first rule is to stop using the brittle locators. Avoid using long XPaths or dynamic classes like the BT button primary 99 or some random CSS dynamic classes because they change every time and they are not reliable. So instead, you should use user-facing locators. As explained in the official Playwright locator best practices, as you can see, you can take a look at this site. I will leave this link in description, and according to this official documentation, it is always recommended that you should pick attributes that match how a real human interacts with a page. So a real human, what will he do? He will look at the buttons, he will look at the links, he will look at the buttons, the labels, and all those things. So these attributes stay stable even when the background code changes. A button is always a button. Even when the buy us a coffee button is orange, tomorrow if the button changes to some other color like brown or purple, it is still a button. So that's how a human will look at this page and you will go and click the button. So in the same way, you should use these stable attributes as your Playwright locators. So Playwright locators are also strict and lazy. And when a Playwright looks for a button, they re-evaluate automatically right before taking an action. Let's say you have a Playwright script that tries to click on this button. So before taking that click action, Playwright always re-evaluates automatically and whether the button is really there, so which helps avoid stale errors. The second big mistake is using hard-coded sleep delays like page.waitForTimeout, like this page.waitForTimeout of 5 seconds. These fixed delays make your tests very slow when the application is fast, and they still fail when the server is slow. So instead, you should rely on Playwright's auto waiting. So before clicking on a button or typing anything, Playwright automatically checks if an element is visible or it is stable or whether it is enabled and it is really ready for action. So let's jump into the VS Code. The first VS Code that we have, the Playwright test we have is this is the test. So what this test does, when I run the script, what it does, it goes to the site, enters a human username and password, and then you can see here how this test uses the stable getByLabel and getByRole. So what this means is when it goes and looks at the page, there is a username and password form, and you can see the site here. This is a login page. So what we are saying, we are not using any HTML ID to identify the username, password, or the button. We use the stable locators, which is getByLabel and getByRole. So what these does is they look at the site just like a human being sees the site. For example, when you go to the site, a human being will look at this form and say, oh, I see a username here and a password here. let me go and fill the details. In the same way, you should write the script that way. So user facing locators means you tell the playwright, look at the site just like a human sees. A human would go and see where is a label called username. Okay, here it is, and I'm going to type my username, and then you say, hey playwright script, look at the page like a real human does. In other words, look for the label password and then go and fill that. So even tomorrow, if your developer accidentally changes the HTML ID or the font of this username, or the username may be shifted to the center of this, and you might do something accidentally. Human errors are always possible when coding, so those style changes or layout changes will not break your script. The script will always go and look at the username and password just like a human being. Tomorrow, if you see this username move to this area, as a human being you will still understand, oh, that's still a username, and you will go and type it correctly. So in the same way, and when it comes to clicking on a button here, we still don't use the HTML ID of the button. We say getByRole. These are the area locators, and you can see here when you mouse over, you can see the real definition, and it says allows locating element by their aria role aria attributes. So I have explained what is aria role and aria attributes in another video, but for this video you just need to understand that you should use the getByLabel or the getByRole. Role is what is the element's role. This is a button. So there is a button, you tell the playwright to look for the button, and there are many buttons on the page, but as a human being, how will you look at the button on the page? You will see this is not a login button because you see this has a name, buy us a coffee. So you will go and look for the button that has the name login. So in the same way, you mimic how a human being interacts with the user facing application. So you want the script to look for a button with a name login, and then click and then perform the action. And playwright automatically waits for this button to first be stable on the page and it is really ready for that click action. Only then it will go and click. So you don't need to add any explicit waits or sleeps. Playwright takes care of that and makes sure that the button is actually loaded on the page. So as soon as the button loads on the page, it goes and clicks, performs the action. So let's run this test and see, and you can see that it runs fine, and it goes there, fills in the username and password, and then it logs in. So the test passed. So this is how you need to understand how to use this reliable user-facing locators. They are more resilient to dynamic CSS or ID changes. So don't use the CSS or ID. They always change and they are not that reliable. So moving on to the next example is this page, which is another scenario where you have dynamic loading page. So here, for example, you have a button start, and when the test clicks on this button, and this loading is very dynamic. It may take 1 second, 2 seconds. So in this case, it takes 4 seconds or 5 seconds, and then it finally loads the message, hello world. So when the test runs again, and if you have a hard-coded wait time, let's say 2 seconds, and if this loading takes more than 2 seconds, it's going to be failing. And some other day, this might load in 1 second. So that's where the flakiness comes. So we here have the script to go to this dynamic loading page, and then, as I said before, use the getByRole button. So it clicks reliably on the start button, and as soon as it starts, it's waiting for the heading, that is the H1 or H2, this heading with the name hello world, to be visible. So let's try and run this test and see how it works. So we did not add any sleep. So it clicks on the start, and the default wait time is 5 seconds, but here the test fails because the loading took more than the default 5 seconds, so the Playwright timed out. So that's why the Playwright's default assertion timeout is 5 seconds, but our slow backend API took 6 seconds to respond. So how do we fix this flakiness, this type of issue? So what we need to do is explicitly specify the hard-coded, increase the timeout by explicitly specifying this parameter called the, so as you can see here, so previously the to be visible doesn't have that overriding. If you leave this empty, it takes the default 5 seconds, but here we want to increase the 5 seconds to give a little more wait time. So we are going to put a timeout of 10,000 milliseconds, that is equal to 10 seconds. So this is the original script with a default timeout of 5 seconds, and now we are overriding that and increasing the time to 10 seconds. So let's rerun the test and see. So here it's going to click the start button, and so that's how it passed this time. So we pass a custom timeout option directly to the to be visible. So you don't have to worry about this 10 seconds. This is not a hard-coded 10 seconds. Playwright won't wait the full 10 seconds if the element appears in 6 seconds, for example. For example, the element appears in 6 seconds. It is not going to wait for the whole 10 seconds. As soon as the hello world appears in 6 seconds, it's going to come out of this step because it sees that hello world is visible. So it's going to come out of this as soon as the 6 seconds reached, at which point the label hello world appeared on the screen. So that's how it resolves to the exact millisecond the element renders. So as soon as the element renders, it's going to check the visibility. It's visible. So at the sixth second, it's going to come out of this line and move to the next line. It is not going to stay here in this line for 10 seconds and then go and check the element is visible. So that's how you need to understand this. So, and here is another example where you need to target a specific item inside a complex dynamic row. So here we do not write a complex parent XPath. Suppose you want to click this edit button, you don't need to find the XPath. You need to use Playwright's chaining and filtering. So let's look at our third VS Code example here. So here it goes to the same tables page, and you can see here we chained our locators. So as soon as the page loads, we get by role of the row. So it gets all the rows. So there are many rows on the page, and then we filter the rows. So what we do is find the row that has the text jsmith@gmail.com. So this is obviously a unique value you should provide. There should be only one unique value, one row that has this unique value. So it finds the first row which matches the text, has the text jsmith, and then it remembers we stored that row in this constant, and then you say go to that row and get the link with the name edit. So it goes to this row and then finds the button with the name or the link with the name. Even the button will work, but the important thing is the name with the edit, and then it clicks. And then once it clicks the edit button, it expects the page to have the URL to be, that is the URL in the address bar, to have the hash edit or pound sign. So that's how you use the Playwright's chaining and filtering. So first you filter, and then you store that here into this constant, and then chain that constant on and use that constant, and then say on that row find a link. So you chaining it first you're filtering it and then you're changing it. So you're digging deeper, you're filtering, you're putting more specific conditions to identify that particular row. Once you identify the row, you put another condition to find the button within that row and then perform the action. So let's run this test and see how it goes. So you can see the address bar is going to change, but here the test failed. So what is this? What is the error we see here? So here the test failed and we need to resolve this cleanly. So the problem is, when you say getByRole and find a link with the name edits, there are many edit link on this page. And if you say .click, the Playwright will see many edit buttons on the page and then it will go and click on one of them. But which one to click? That's why it failed. So what is your goal in this test? If your goal is to click the first edit link, then you need to properly specify that. So to resolve this cleanly, we need to add .first. That means pick the first link with the name edit and then do. Now Playwright does not have that confusion. So now it clearly knows, oh, that's the first edit button I need to click. So it clicks it and then checks the URL has that pound sign added. So let's run this test again, and this time, so we can see the URL here, the hash edit. So you can see here the hash edit appeared and the test passed. So things like this, unexpected pop-ups like cookie consents or promo banners, they also cause random failures in the CI/CD, such as the Jenkins, for example. So instead of writing the messy try-catch blocks everywhere in your code, you should always use the Playwright's page.addLocatorHandler. So you can read more on this, the Playwright's documentation, but this is the Playwright.addLocator. So that's the add locator. So you can read more about that in the documentation. So basically, when the Playwright spots that any overlay blocking things such as a pop-up, for example, when it tries to click this edit, suddenly an unexpected advertisement pop-up might occur. So Playwright spots those blocking those things that block this action. So it automatically runs the handler, it closes the pop-up and continues your test execution without any failures. And finally, when a test fails in your pipeline, do not guess why. Turn on the Playwright's Trace Viewer. So you can simply go online and search for the Playwright's Trace Viewer, and you should always say on the first and set the first retry by setting the trace on first retry in your playwright.config.ts file. So in your playwright.config.ts file, so I have explained more in detail in another video, but you have to edit this file, and here is that file. So you have to do the setting here, so trace. So what happens is, it will turn on the Playwright's Trace Viewer. So this Trace Viewer will give you the full DOM snapshots, the exact content of the page at the time, and the action logs and the network details before and after every click. So that makes you easy to see when you debug. It makes you easy to see if an element was missing or it is hidden. So so you can understand the state of the page when that failure happened. So to review, we saw that we should always replace the fixed sleep timers with auto waiting, and pass custom assertion timeouts for slow APIs, and drop dynamic CSS classes for the better getByRole and handle the strict mode violations with the dot first, so that reduces the ambiguity in your test. And also you can handle the pop-ups with locator handlers. So if you enjoyed this video, please click on the like button, subscribe to this channel, and check the description box for links to the sample code and the official Playwright documentation.